All right, in today's lesson, we're going to look at how to graph a variety of functions, including linear, quadratic, cubic, absolute values, square root, and cube roots. Now, to get a general sense of what these graphs look like, we're going to graph each of their parent functions, which is the most basic form of that function. And then we're going to look at some of the key characteristics. So let's get started. We got linear function first. F of x equals x. So we have y equals x. Now, when I'm plotting or trying to figure out what the parent function looks like, or plotting any graph for that matter, I'm always going to try to plot some values that are positive as well as negative to kind of get a general sense of what this graph looks like. And you want to plug in nice, easy values. So maybe we choose -3, -2, -1, 0, 1, 2, and 3. All right, so when I plug in -3, what do I get out? F of -3 is -3. -2 gives me out -2, -1, -1, 0, 0, 1, 2, 3. So let's plot those points. We got -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. And as you can see, these points that I'm plotting are creating a line for linear. Now, we need to look at some key characteristics. First off, what's the x-intercept? That's where the graph crosses the x-axis, which is at 0. So when you write the x-intercept, guys, make sure you're writing it as an ordered pair. So x is 0, y is 0. Y-intercept is where the graph crosses the y-axis. Well, again, that's at 0, 0. Domain and range. Now, we're going to use interval notation since we talked about that in the previous lesson. And moving forward, we're really going to stick with interval notation more so than set notation. So for my domain, every x value is hit from left to right. And my y values, for my range, every single y value is hit as well. So my domain and range are both -infinity to infinity. Again, for infinity and -infinity, we use parentheses, not brackets. All right, relative max. Is there a highest point on this graph? Nope, so none. Relative min, is there a lowest point? Nope, none. Intervals of increasing. So from left to right, notice this has a positive slope, so it is always increasing. It is never decreasing. And in line of symmetry, is there a line of symmetry that makes this symmetric on both sides? And we'll say yes at x equals 0. All right, let's look at our next function, which is a quadratic. So we get f of x equals x squared. Again, I'm going to plug some values that are negative and positive, -3, -2, -1, 0, 1, 2, 3. So when I plug -3 in, -3 squared is +9. -2 squared is +4, -1 squared is 1, 0 squared is still 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So -3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, 4, 1, 2, 3, 4. -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. And you can see here we have a U-shaped graph for this quadratic. Remember, that is called a parabola. X-intercepts, so it crosses the x-axis at 0, 0. Y-intercept is also 0, 0. My domain is all possible x values. We'll notice the arrows are both going up, and they're going on forever. So that means technically every single x value is going to be included in this domain. For my range, when we go bottom to top, I don't have any y values that hit until I hit 0. 0 is part of that graph, so it's included, so it's going to get a bracket. And then every y value after that's included, so we'll go 0 to infinity. Is there a relative max? Nope, the graph just keeps getting bigger and bigger and bigger, so there is no relative max. Relative min, is there a lowest point on this graph? Yes, there is. It's at our vertex, which is 0, 0. Intervals of increasing. So where do we have a positive slope? It starts at 0 and goes to infinity. Where do we have a negative slope? Well, from negative infinity to 0. Remember, guys, intervals of increasing and decreasing always get parentheses. Line of symmetry, is there a line that will make this parabola symmetric on both sides? Yes, there's always an axis of symmetry with a parabola. It's at x equals 0 for this one. All right, moving on to our next function. We have cubic. F of x equals x cubed. So again, -3, -2, -1, 0, 1, 2, 3. -3 cubed is -27. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. All right, so clearly this -27 goes off the graph, so you're going to just kind of estimate where this is at. So I'm going to the left 3, down -27, somewhere down here. -2, -8, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0, 1, 1, 2, 8, and 327, again, far off the graph. So if you have a general sense of what this graph looks like, looks something like this. That is our cubic function. X-intercept, so 0, 0. Y-intercept also 0, 0. Domain is all possible x values. Well, take a look at the graph. From the left side, the arrow keeps going down. The right side, the arrow keeps going up. So everything is included in my domain and my range. Relative max, there is none. There's no highest point. There's also no lowest point because they keep going in both directions. Interval of increasing, well, from left to right, we always have a positive slope. So negative infinity to infinity. Decreasing, none. Then for the line of symmetry, on a cubic function, there is no line of symmetry. That's going to make it two symmetrical parts. Moving forward, we got the square root function. So for a square root function, well, let's think about this logically. I can't plug in any negative values for a square root because if you think about what's the square root of a negative, if you try typing it in on your calculator, you're going to see it's undefined because there is no number that I can multiply by itself that will give me out a negative, right? A negative times a negative is a positive times a positive is a positive. Never going to get out a negative. So we have to pick values that are bigger than or equal to 0. So let's do 0, 1. We don't know the square root of 2, some decimal, so let's do something we know. Square root of 4 we know, so we know the square root of 16. All right, so 0. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 16 is 4. All right, so let's plot these points. 0, 0, 1, 1, 2, 3, 4, 2, and then 16, 4 somewhere over here. So you can see for a square root function, it starts at an endpoint and continues on forever in one direction. X-intercept, again, is 0, 0. Same with the y-intercept. My domain starts at 0. It's included, and it goes on forever to infinity. My range, from bottom to top, it starts at 0, and it goes on forever to infinity. Relative max, there is none. For relative minimum, there is no lowest point. And then for interval of increasing, so where do we have a positive slope? From 0 to infinity. There is no interval that it's decreasing or have a negative slope, and there is no line of symmetry. All right, moving on, we got cube root function up top. So f of x equals the cube root of x. So let's think about values that we know. We know the cube root of 8 is 2. We know that the cube root of 1 is 1. We know that the cube root of 0 is 0. We know that the cube root of -1 is -1. Cube root of -8 is -2. So let's plot those. We got 8, 2, 1, 1, 0, 0, -1, -1, -8, -2. And there is my cube root function. X-intercept is still 0, 0. Same with the y-intercept. Domain, -infinity to infinity. Same with the range. Relative max and mins, there are none. Interval of increasing, so from left to right. It's always increasing, it's never decreasing. And there is no line of symmetry. All right, and for our last function of the day, we have absolute value function. So absolute value of -3 is 3, -2 is 2, -1 is 1, 0 is 0, 1 is 1, 2 is 2, 3 is 3. Remember, when you take the absolute value of any number, it's positive because by definition, the absolute value is the distance away from 0, and there is only a positive distance away from 0. So that is why all of our y values end up being positive. So let's plot those. -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. And we could obviously keep going. But that is the general graph. X-intercept, 0, 0. Same with the y-intercept. Domain is all possible x values, which are all included. So -infinity to infinity. My range starts at 0 and goes on forever after that to infinity. There is no relative max. This time we have a relative min at 0, 0. Interval of increasing is from 0 to infinity. That's where we have a positive slope. Negative slope is from -infinity to 0. Again, don't forget intervals always of increasing and decreasing always get parentheses. And then we have that line of symmetry at x equals 0.